you apply formulas to find the area of composite figures? Think about this question during the lesson. Delia drew this figure. How can you apply formulas to find its area? You can decompose a composite figure into smaller polygons. The sum of the areas of the smaller polygons is equal to the area of the original figure. Step 1. Decompose the figure into shapes whose area formulas you know. You can decompose this figure into a trapezoid, a parallelogram, and a triangle. Step 2. Apply the formulas for the areas of a trapezoid, a parallelogram, and a triangle. What is the total area of the figure?
Select your answer.
The total area is equal to the area of the trapezoid plus the area of the parallelogram plus the area of the triangle. The area of the trapezoid is 63 square centimeters. The area of the parallelogram is 28 square centimeters. The area of the triangle is 21 square centimeters. The area of the figure is 112 square centimeters.
Johnson decomposed the same figure in a different way. Show that he will find the same area that Delia did.
Okay, so Johnson has the area of triangle, an area of a parallelogram, and then he broke up this bottom figure into 1, 2, 3 triangles. So first, the area of the parallelogram. The parallelogram is base times height. So we have the triangle. I want to start with the triangle. So we have a total of 1, 2, 3, 4. So that's where this 4 comes from. So that 4 is also going to go here. And then the half comes from the formula for a triangle here, and then base and height. So they're all the same shaped and sized triangles. So the numbers are going to be the same for each one. So it's 7 and 6. And then we have the parallelogram, which we have the base at 7 and the height at 4. So that will go here. Now we just saw 7 times 4 is 28. And then here, okay, they want us to solve all of it. So first we can do 7 times 6, or you can do 1/2 times 6 or whatever. So if we did 1/2 times 6, for example, that would be 3. And then 3 times 7 is 21. And then 4 times 21 would be 84. And then 84 plus 28 would equal 112 centimeters squared. So the total area is 112 centimeters squared. So even though they solved it using different formulas, they still were able to get to that same area.
Josie has set aside some space in her bedroom to use for exercise. Find the area of her exercise space.
One way we can solve this is by taking this bedroom and cutting it up into, or decomposing it into shapes we know formulas for. So as you see here, they have drawn this dotted line to separate this into a rhombus and a trapezoid. So the formula for a trapezoid is here, which is area equals 1/2 times base 1 plus base 2 times the height. That's here, and they solved that and got 15 feet squared. And then for a rhombus, it's area equals base times height. So all of the sides are the same length. And so we have 5 times, I'm sorry, they're not all the same length. My apologies. The height of this is 4. And so base times height is 5 times 4. And you get 20 feet. And then when you add them together, you get your 35 square feet total. Now you look at the other way, and they decomposed it a bit different. So they kept the dotted line for the trapezoid, but then they separated the parallelogram into a triangle and another trapezoid. So now we have 2 trapezoids. So we use the formula twice this time and solve for it. And then we have the area of a triangle, which is area equals 1/2 times base times height. And you get your area for that. And then once you add them all up, you still equal to your 35 square feet. I also wanted to point out in both scenarios how they got the height of this second parallelogram or trapezoid and triangle as 4. If you look at this one, the height again goes up and down for this shape. So if you look, this side of this trapezoid is 7 feet. We don't have a line going straight down here, but we can imagine that it's there. And then this side of that line is 3 feet. So if these lines, so say we drew a line here, that'll be a rectangle. So this side and this side would be the same length. So this would be 7 feet. This would also be 7 feet. So I can take that 7 feet and subtract it from the 3 feet, and I would get 4 feet. So that's how they got the height. I just wanted to make sure I pointed that out because they did not point that out when they solved this for you.
Show that the composite figure and the trapezoid have the same area. Then find the area.
Drag the familiar shapes onto the composite figure and the trapezoid. Okay, so we can put a triangle here, a little, that moves. Okay, triangle here, move that down. Oh, still got twisted. Okay, that's good enough. And then rectangle here, so I got 3 there. With this one, I'll put it there. Rectangle here, and then this little guy turn the other way. Oh, there. Thought I had it. There we go. Oh, this thing is tricky. And that's almost perfect. And then there's the idea. So you find these little shapes and you fit them in to make the composite shape. Now that we've done that, we can use those same figures to solve them. So you have all the measurements for all the different sides. So you see now we have the different figures, excuse me, and they have the measurements, and then they apply them into the formulas for the rectangle, for the triangles, and then you add them all up, and that gives you the same area of 132 and 5/10 meters squared for both ways. Find the area of the composite figure. So we're going to separate this into shapes we know. And as you saw in the previous examples, there are different ways to separate a composite figure. There's no wrong way. It's just whatever works for you. So let's see what works for me. All right, so we are going to do this. I am going to use a different color. Okay, I'm going to extend, that's not straight at all, but let me try that one more time. I'm going to extend, that's better, this shape to be a parallelogram. And a parallelogram formula is area is equal to base times height. So we know base 1 and base 2, I'm sorry, the base here is 25 and our height is shown here with the 4 and 4 equals 8. So we have 8 times 4. I didn't write it in the right order, but I mean not 4. 8 times, let me just write it in the right order so I'm not confusing anyone. Okay, so the base is 25 times the height of 8. And so 25 times 8 is 200. So that'll be 200 for the parallelogram. Now, this is not a parallelogram, but to find the area of this shape, we had to create or extend it to look like a parallelogram. Now we have to find the area of this triangle here, and the formula for a triangle is area is equal to 1/2 times base times height. So now we take the base, which would be here, and we don't know what that equals, but we can solve for it. So we take 25, because it's a parallelogram, the sides are equal. So if we do 25 minus 15, that is equal to 10 inches. Excuse me. And the height of our triangle is that 4 inches there. So we have 1/2 times 10 times 4. And then because we're multiplying straight across, you may multiply these numbers in any order, and you should still get the same answer. So 1/2 times 10 is equal to 5. And then I'm left with 5 times 4. And then 5 times 4 is 20. So the area of this triangle here is 20. Now, because I added this on so that I could find the area of this total shape, I only need the area of the purple part. So I'm going to take the area of the triangle I added and I'm going to subtract it. So now I'm just going to choose a different color. I'm going to take the 200 from the parallelogram and subtract the 20 from the triangle I drew. And then that's going to equal 180. And so the area of this composite figure is 180 inches squared. So again, this is the way that I decided to solve it. You may have a different approach, but I wanted to show you my way. And of course, as I mentioned before, there are multiple ways to possibly solve any find area for any composite figure in more than one way.